very clear. So whenever your system is going to work, okay, so it is very clear. The input format is decimal and system processing format is binary and storage format is hexa and again output format is decimal. Okay, so this is very clear. This is the only reason we are trying to understand all the number conversions from your binary, hexa, octal, hexadecimal, all this. Okay, the purpose to clear. Now I want to do with microcontroller, and you know already why microcontroller is far better than your microprocessor system. Okay, so whereas electronic system using processor is different and electronic system using controller is different, right? So whereas processor required all the external components like memory and PPIs. So these are all the additional components whenever you are doing application with processor. Okay. Whereas controller, so you are taking external memory for processors and external PPIs, adding your PPIs for your input device and as well as output device. And this PPI will take care of converting your information to zeros and ones. And again, processor is going to give the information in output again the same format as zeros and ones. Okay, by fetching the suitable instructions from memory and then give the output. Okay, so whereas controller, it is simply replaced with all together in a single chip, whereas with inbuilt processor, with inbuilt memory and IO ports, and with even other features. So here I can directly connect my input and I can directly connect my output. So this is how the simple electronic system using processor and electronic system using microcontrollers. Okay. So the differences between microprocessor versus microcontroller are asked. Whereas no memory, on-chip memory, no I/O ports, on-chip I/O ports, more complexity, less complexity, more power consumption, less power consumption. So these are all the differences we are finding between processor and controller. Now we are more focusing on microcontrollers in embedded technology. So the major reason behind this is because the controllers have become one chip solution for any kind of product or any kind of solution. Okay, rather than making application with processor, we are proceeding with controllers. 8051, Arduino, PIC microcontrollers, ARM controllers, every project, we are trying to use only controllers rather than processors. Okay, processor based applications are very complex compared to microcontroller based products. Okay, so this is the only reason we are talking about microcontrollers in embedded technology. Now, what is your microcontroller block diagram basically? And you know already the versions of microcontrollers. There are 8-bit microcontrollers, 16-bit microcontrollers, 32-bit microcontrollers in the market. Now, you just started our journey with basic microcontroller, which is 8-bit. That too from 1980s, we introduced a microcontroller which but today's year is 2024. So in 2024, so there is no 8-bit microcontroller based product in real time. But still, why you are going to learn this 8-bit microcontroller? Without understanding 8-bit microcontroller, there is no chance to understand 16-bit. Without understanding 16-bit, there is no chance to understand 32. Okay, because it is a generations of devices. There is no chance to learn direct 64-bit and you can directly go for Intel company. It is not possible. Okay, so always you have to focus the basic device and you have to very clear on this basic device, because for any device the terminology is same, which means architecture, bit capacity, address bus, data bus, memories. These are all the fundamental concepts for any device. Okay, this terminology manaki ekkadiki continue avutundi. Only difference is the generation will be more or higher generations of your 8-bit is 16-bit and 16-bit higher generation is 32-bit and 32-bit higher generation is 64-bit. Okay, how to understand 8-bit microcontroller first? So, 8-bit microcontroller gunchi poortiga telisa telida. So that you have to discuss. If you refer the microcontroller block diagram, it is very simple. What block diagram tells us? Asalu block diagram nunchi mana em nechukochu. Okay, so whatever they are telling here, which is integration of processor, integration of memory, and integration of IO ports with some other features, I just complete these blocks with some clear picture. Let's see. The microcontroller block diagram is very clear. It consists of one CPU inside and connected with some buses. There is a section of RAM and another section of ROM. And the next block from microcontroller block diagram is IO ports. And next block is timers, counters. And interrupts. And serial port. Okay, so this is how the blocks from microcontroller you can find it: RAM, ROM, IO ports, timers, counters, interrupts, and serial port, which consists of one CPU. So what is CPU here? Central Processing Unit. Indirectly it is a processor only. మనం ఇందాక చెప్తున్నట్టు ఒక మైక్రోకంట్రోలర్ లో ఇన్బిల్ట్ ఏమేమి ఉంటాయని చెప్తున్నాం. ప్రాసెసర్, అమౌంట్ ఆఫ్ మెమరీస్ అండ్ IO ports. సో ఈ బ్లాక్ డయాగ్రామ్ చూస్తే మీకు సో మోస్ట్లీ it is a processor, and again there are types of memories: RAM memory and ROM memory and IO ports. What are the additional features here? Timers, counters, interrupts, and serial port. Now you should understand the clear importance of each block from microcontroller. First, what is CPU here, and what is the information you need to know from CPU? Every microcontroller having one CPU inside compulsory. So not only 8-bit, even you start reading about 32-bit microcontroller. So 32-bit